Your Hangman game now correctly handles guesses of letters that are in the phrase and letters that are not in the phrase. But what should the program do if someone enters invalid data, such as a guess with more than one letter or a character that's not even an alphabetic letter? You should always try to write your programs to handle invalid data. In this lesson, I'll show you how to handle several cases of bad data that the user might accidentally or purposely try to enter. Then we'll allow the user to keep guessing to play a complete game. Hi, I'm Annette Gotland. I'm the author of the Do-It-Yourself Java Games books. I teach Java programming through creating games. Welcome to the video version of my books. We're currently in the Text Games video series, TG, the first of 4 types of games series. The focus of this series is to cover the fundamentals of Java programming. You'll learn how, when, and why Java programs are written the way they are. This series has 16 projects. Each project assumes you already have the skills taught in the previous projects. A link to the entire Text Games playlist is provided in the description below. We're currently working on the 15th project, TG15 Hangman. You'll be given a puzzle that shows how many words are in the phrase and how many letters are in each word, like this. If you guess a correct letter, the puzzle will show every place it's used in the phrase. If you guess an incorrect letter, that letter will be added to the list of wrong guesses, and another part of the stickman will be added to the hangman gallows. The object is to guess the phrase before all 10 parts of the stickman are drawn. This is lesson TG15.4, where you will check if the user's input is valid before you use it. It's time to let the user guess the letters. In fact, you should let the user keep guessing letters until the end of the game. When should the game end? When the puzzle is solved or when the stickman is complete. Exercise 1. Allow repeated guesses. Pause the video if you need more time in any of these exercises. If you want to see how I would complete any of the listings, please refer to the completed listings at the end of this video. In the constructor, put a while loop around all the code from the declaration of guess through the second time it prints the puzzle. Continue the loop while there are dashes in clue and the stickman isn't complete. Hint: use strings contains method to check if the string contains a dash. Hint: use strings length method on wrong letters to check if 10 letters have been guessed yet. Then change guess to now prompt the user to guess a letter. Hint: use my Windows prompt for string method. Run it. What happened? It should have let you keep entering guesses until you either guessed the phrase or guessed 10 wrong letters. If you play the game, it probably won't take you very long to see it doesn't handle bad input very well. Let's start with handling the invalid case of entering more than one letter. Exercise 2. Guess must be one letter. After they enter a guess, convert guess to uppercase. Then, if they enter more than one letter, print an error message and ask them to try again. Don't add the invalid guess to wrong letters. Run it. What happened? If you enter a guess more than one letter long, it should print an error message and ask you to guess again. No change should be made to the list of wrong letters nor to the stickman in the gallows. Next, let's handle the invalid case of guessing the same letter more than once. Exercise 3. Stop duplicate guesses. After handling the length of guess, check if the user already guessed that letter. If so, ask them to try again. Hint: all previously guessed letters are in clue or in wrong letters. Then be sure not to add the duplicate guess to clue nor add it to wrong letters. Run it. What happened? If you enter a previously guessed letter, regardless whether it was in the phrase or in the list of wrong letters, it should print an error message and ask you to enter another guess. No change should be made to the list of wrong letters nor to the stickman in the gallows. You should also require that guesses be alphabetic. There are multiple ways to check if a character is alphabetic. One easy way is to create a string of all the letters of the alphabet, then use the contains method to check if the alphabet string contains that letter. But since we just introduced character data types in this project, let's check if a letter is alphabetic by using character data. As character data, you can easily check if a character is between the values of A and Z. Exercise 4. Require alphabetic guesses. If the guess hadn't been guessed before, create a character named character with an initial value of the character in guess. Hint: use strings char@at method to get the character in guess. Then, if character is not alphabetic, ask them to try again. Hint: if the uppercase version of the character is less than a capital A or greater than a capital Z, then it's not an alphabetic character. Hint: use single quotes around character data. Hint: compare characters using equal signs, less than signs, or greater than signs. Then, be sure not to add the duplicate guess to clue or add it to wrong letters. Hint: move the code that handles valid guesses into an else block. Run it. What happened? If you entered a non-alphabetic character, it should print an error message and ask you to enter another guess. Entering alphabetic characters should still work correctly. No change should be made to the list of wrong letters, nor to the stickman and the gallows. The loop ended because the user either solved the puzzle or made 10 wrong guesses. Now you should congratulate the user if they solved the puzzle. Exercise 5. Congratulate success. After the while loop, congratulate the user if they solved the puzzle. Hint: the puzzle was solved if there are no dashes left in the clue. Otherwise, if the user didn't solve the puzzle, tell them what the phrase was. Run it. What happened? If you guessed the phrase in less than 10 guesses, you should get a congratulations message. If your 10th guess was a letter not in the phrase, it should tell you what the phrase was. Key points and more. Prevent invalid input. When you write programs that require user input, you should make sure that no invalid data may be entered. For example, require a minimum or maximum number of characters. Require a specific type of data, such as numeric or alphabetic. Restrict allowed data to be from a set of potential values, such as yes or no. Restrict allowed values to be from a specific range of values, such as between 1 and 100 or between A and Z. Key points and more. Compare character values. Use numerical operators to compare character values. For example, equals, greater than, or less than. Comparing character values compares their Unicode values. Uppercase A through Z have decimal Unicode values of 65 through 90. Lowercase a through Z have decimal Unicode values of 97 through 122. So be aware that when you want to test for alphabetic characters, you must test different ranges for uppercase and lowercase letters. You can reduce the number of tests required by first converting all characters to uppercase or lowercase before you compare them. Here are the completed listings for all the exercises in this video. This is the end of the 4th lesson in the Hangman project. Your program now plays a pretty good game of Hangman, but your Hangman game would definitely be more fun to play if it chose a different phrase every time you played it. So in the next lesson, you'll learn how to read all the lines of a file when you don't know how many lines will be in that file.